Hi, I am Gayatri, and today I'm going to talk about cluster sampling. We have talked a lot about different designs during our lectures, that is, simple random sampling, systematic sampling, and stratified sampling. So, today I will give an overview of cluster sampling. So, let's get started. Let us start with an introduction. So, in cluster sampling, what we do is we will divide the population into groups called clusters, and so the sampling unit is no more the element or population unit, but it is the cluster. Let us understand this with an example. So, suppose we have the sampling frame of list of addresses. So, now here in this case, household will be the cluster that we want to sample, and the population unit is the people living within the household. Similarly, if the sampling frame is list of city blocks, then our cluster will be block and population unit will be household. So as I have mentioned that here we will no longer assume that sampling unit is equals to element in cluster sampling, but it is the cluster. Also in cluster sampling, we select all the population unit from the selected cluster. Let us now understand what are clusters. So primary sampling unit is what we define to be clusters. Let us understand this with an example. So I have got this example where I have different households here. So the total number of clusters here is 11, and suppose now we want to take the SRS of four sampling units. So after taking the SRS here, a small n will be our 4, that is the 4 primary sampling units. And since we are taking the all the population units from the selected clusters, so total unit will be our 28, that is the 3 population unit from cluster 1, 5 population unit from cluster 4, 12 from cluster 7, and 8 from cluster 11. So when do we use cluster sampling? So we use it when it is economically justified, that is when cost saving overcome loss in precision, or when constructing a complete list based sampling frame is difficult, expensive, or impossible. Also we use it when the population is in the natural clusters, like schools, city blocks, households, etc. So there are different types of cluster sampling, that is one stage sample and multi-stage sample. In one stage sample, what we do is first we select the clusters, then all the population unit in the sampled clusters are selected for the survey, and the unit chosen at this stage is known as primary sampling units. However, in multi-stage cluster sample, the sampling is carried out in more than one stage. So first we select the clusters, and the population unit that we selected at the first stage are then sampled in the second stage, and unit chosen in second stage is known as the secondary sampling unit. People are often confused with stratified and cluster sampling. So what is the difference between the two? So in cluster sampling, cluster is treated as the sampling unit, and sampling is done on all the population of the selected clusters, and only the selected clusters are then sampled. However, in stratified sampling, the sampling is done on elements within each stratum, and the random sample is drawn from each of the strata, so we include all the strata in this sample. So let us understand this with an example. So in stratified sampling, what we do is we split our population into strata. So here we have got 11 strata, and then we take the SRS from every stratum. So for instance, from stratum 1, I have taken the SRS of 1 unit. From stratum 2, I have taken the SRS of 1 unit again. From stratum 2, 3, 1. From stratum 4, 1, and so on. So here n1 is equals to 1, n2 equals to 1, n3 is equals to 1, and so on. So in this case, capital H will be equals to 11, that is the total number of strata, and the sum of all the population unit of the total number of strata is equals to 65 in this case. Also, small n is equals to 27 units, that is the total number of population unit of the sampled strata. But in cluster sampling, each block is cluster. So suppose we have selected cluster 3, cluster 9 and cluster 10. So what we do is take an SRS of clusters and observe all the elements within the clusters in this sample. So here I have taken the SRS of three clusters. So capital N will be equals to 11, that is the total number of clusters, and small n, that is the sample clusters, is equals to 3. Also, since we are observing all the elements within the clusters in the sample, so our total units will be equals to sum of the sampled clusters. So cluster 1 has 6 units, cluster 3 has 6 units, cluster 9 has 6 units again, and cluster 10 has 5 units. So in total it is 17 units. So let us look at the notations of the cluster sampling. Suppose the population is divided into n clusters, then small n will be our number of clusters selected in the simple random sampling. Small mi is the number of elements in the clusters, and I is from 1 to n, that is the total number of clusters. M bar will be the estimated average cluster size for the sample. Capital M is the number of elements in the population, and M bar will be equals to capital M, that is the summation of Mi, upon capital N, that is the average cluster size for the. And then Yij is the value of jth unit in the ith cluster. Ti is equals to the total of ith sampled cluster, that is the sum of Yij. Capital T is the population total, Yi bar is the mean of the ith cluster, and capital Y bar is the population mean. To get the estimation of population total, suppose T hat is the numberist estimator of population total M, such that T hat is equals to capital N upon small n multiplied by the summation of Ti, where small ti is equals to total ith sampled cluster. And then the variance of T hat is given by this formula, where St square is equals to population variance, and given by this formula, where the capital T upon capital N is equals to population mean, and the standard error of numberist estimator is just the square root of the variance of the numberist estimator. Let us talk about now the probability of selection of a particular unit. In cluster sampling, number of sample unit in each cluster is proportional to population size of each cluster. So Mi is proportional to Ti, where small mi is the number of sample unit, and Ti is the population size of each cluster. So the probability of selection of a particular unit can be defined by Pi is equals to Mi, small mi, that is the sample unit, divided by capital M, that is the summation of all the mi's, where capital Mi is the number of elements in the population. Then for sample cluster I, we observe small ti is summation of Yij, so we will use small t hat k is equals to Ti upon Pi, where Pi is the probability of selection of particular unit if the cluster I is selected at the gear draw. To get the estimate of the population mean, first we will calculate the value of number raised estimator by using the formula on the slide 10. Then the mean of a population mean is given by the T hat upon summation of Mi, where T hat is number raised estimator and capital M is equals to number of elements in the population. Now to obtain the sampling variance of the population mean, Again, we'll use the formula of variance of t hat from the slide 10, and then the variance of population mean is given by variance of t hat upon capital M, and since capital M is constant, it will come out and get squared, and we'll put the value of variance of t hat from the slide 10, and st square is the value of the population mean, where capital T upon n is the population mean. Let us now talk about intra-class correlation coefficient. Intra-class correlation is a measure of within cluster homogeneity, and it is used only where the number of unit in each cluster is equal. So in this case, in the case of intra-class correlation, we have mi, small mi is just equals to m, that is the total number of units in each cluster. Now it is only the correlation coefficient, so the interclass correlation coefficient is equal to the formula of the correlation coefficient, that is rho is given by covariance of yik and divided by its subsequent square root of the variances. And now we can write the formula for the covariance and variances like this, and then we can further write the formula and rearrange like this. So by rearranging the formula of in the last slide, we will get the formula of rho is equals to this, and finally we will get the numerator equals to m multiplied by ssb minus sst, that is the sum of square of between the cluster and sum of square of the total, divided by sum of square of the total and multiplied by 1 minus m minus 1, and we can rewrite it as like this. Now what is design effect? So for cluster sampling, design effect compares the respective sampling variance of the estimates with those attained using the SRS of equivalent size for the same given data, such that the def, that is the design effect, is equals to variance of population mean of cluster sampling divided by variance of population mean of simple random sampling. This is similar to that we have done for the stratified sampling and systematic sampling, where the design effect for stratified sampling is variance of stratified sampling divided by variance of SRS, and for systematic it is variance of systematic divided by variance of SRS. So it has the link with the intra-class coefficient. So the variance under simple random cluster, that is SRC sampling, satisfy the variance of SRC, that is the simple random cluster, is equals to variance of SRS of population mean multiplied by 1 plus m minus 1 multiplied by rho, that is the intra-class correlation coefficient. So before understanding what is effective sample size, let us look at the some of the usage of design effect. So design effect is used to calculate the sample size. So since we know how to calculate the sample size of SRS, so suppose we have some desired variance V, V can be capital V, can be the margin of error. So using that, under SRS we can easily find the required sample size n star, and given the n star we can calculate the sample size of desired sample size using the design effect by multiplying the n star to the design effect. So n star is our effective sample size here. So effective sample size signifies the number of elements required in each cluster, and it is implicitly related to intra-class correlation by this formula, that is ESS, effective sample size, is equals to 1 upon absolute value of intra-class correlation coefficient. Let us now understand the cluster sampling by looking at the example in the SAS. So I have taken the data from the islands and taken the Birua town as my population from Central Island, and I have capital N equals to 654 here, that is the total number of households there, that is the total number of clusters, and I want to sample the 80 household, so small n is equals to 80 in this case, and capital M, that is the number of elements in the population, is 2104. And now we want to calculate the estimate of population mean of FEV, that is the measure of the lung volume. So before working on the SAS, I have saved the data in the Excel file with the name birua.xlsx, then input the data into SAS, and I have used this code, that is the proc import data file folders, my shortcuts, my folders. This is the location where I have saved the data in my computer. And then xlsx, because it is an Excel file, then I need out equals to birua, because birua is the name of my data, and then run. Now in next step I will randomly select 80 cluster from the population data. To do that, I will use the proc service select function, where data will be my birua, and method I use to select 80 samples is SRS, and a small n, that is the sample clusters, is equals to 80, and I need the output data as SRS underscore birua, and my sampling unit here is household, and then run. So by running the code of the last slides, I got this result where I can see that sample size, that is my small n, is equals to 80, and the selection probability is 0.122. A selection probability is just the small n divided by capital N, and the sampling weight, that is just the reciprocal of selection probability, is 8.175. And here I have shown the first 10 value of my data. Of course I can't show all the 80 values here, so this is the first 10 values of my data. Now we will save the new data in a new file, because we want the value of FEV. So we will now save the new data as a new SRS birua, and then we'll get the value of FEV from each individual of the households. Then to import this data, we'll again use the formula same as before. Then there's one problem that I haven't got the value of FEV from all the individuals. So there are some of the missing value of FEV, so I have to delete those before moving further, otherwise it will give a wrong answer. So I'll use this code. This is if C miss FEV, then delete, that is if there are some missing values of FEV, it is delete those rows, and then we will continue. Then we'll use proc univariate data to get the statistical values of our new data. So by running the code on the last slides, we'll get this result. So now after deleting the missing values, we have capital N is equals to 68, and then all the other statistical values, that is the mean 6.77, variance 12.12, and so on. Now since we have got the missing values and we have deleted those missing values, we have to assign new weights to the data before moving further. So now I have saved a new data temp1 by setting the old data temp. So new FEV, okay, this new FEV equals to FEV divided by 2104 is used to get the value of population mean, and weight SRS, WTSRS, is for the new weight. Now our new weight after deleting the missing values will be 654, that is the total number of clusters, divided by 68 sampled, that is the sampled clusters, and here 2104 is our sum of the total population unit. And then I'll print the data, and data I've got is something like this, where this is the first 10 values of the data with the values of new FEV and WTSRS, that is the new weight. And finally we'll use the survey means to get our estimate of population mean. We can see that total is equals to 654. Number of observation that we want is mean, sum, standard deviation, standard error, variance, and the confidence limits. And variable here now we will use is new FEV because we want the estimate of population mean. And weight we will use new weight, that is WTSRS. So by running this code we observe that now the number of observation here is 68 because I have deleted the missing values. Sum of weight is 654 and the mean of the estimate of the population mean is the value given by sum, that is the 2.105826, and the standard error of the sum, that is the standard error of the population mean, is 0.124260. So these are the references that I have used to make my presentation. There are more. So thank you so much. That is all for my presentation.